A very good morning to the students of class 9, and as we have completed the syllabus for chemistry, we are going for the revision part, and I hope you have got a good concept about the different chapters which is being included in your course, so a chemistry course. And I hope if you have any doubts, you are most welcome to clear it out in the Zoom class. Today we will be having a discussion about the syllabus which is being included in your periodic test 2, that is the structure of atoms. Now this chapter is a very important one. In fact, this chapter will be included in your higher classes as well. So that is why if you are planning to join the science stream, please pay attention and try to clear your concept, because it's a very because atoms, actually what happens, atoms is a very important part, because atoms are considered to be the building blocks of matter, right? And atoms are so small that it cannot be visible with the naked eye, and in fact it requires a very powerful microscope. And in fact if you keep atoms even a powerful microscope is also not possible for you to make it visible to you. So that is why though atoms are so small, but it is actually the fundamental building blocks of matter. That is why atoms and molecules are quite important for us. So what happens here is that when you are talking about atoms, actually the structure, there were various chemists various scientists who tried to give different theories regarding the model of an atom. So it was actually Thomson's model who he tried to give, J.J. Thomson tried to give an explanation about the structure of an atom. And what proposal did he give? He gave that if you think the watermelon, and then you see that the black seeds are embedded in the watermelon. If you cut into two pieces, then what will you find? It is spherical in nature, and then the red part is there, and inside the red part, that is the pulp of the fruit. And inside that pulp of the fruit, the black seeds are being embedded. And according to Thomson, he compared the model of an atom to the Christmas pudding, or and also to the watermelon. So that means what he told, that the electrons are started in a positively charged pair, and the currants or the dry fruits, they are embedded over there, and these actually are like what? They are like the electrons which is being embedded in the positively charged pair. So that is what he told, that the red edible part of watermelon is the positively charged pair, and the black seeds which are embedded are the electrons inside that positively charged pair. So that means what was the proposal of Thomson? That means Thomson proposed that an atom consists of a positively charged pair, and the electrons are embedded or stuck inside it. And the electrons are being placed inside that positively charged pair, and then the negative and the positive charge are equal in magnitude. That means if there are 3 positive charges, it will be the negative charge will also be equal to 3. So that actually, if that is so, that means the positive charge is equal to the negative charge. That means the atom as a whole is neutral. So that means it does not have a charge of its own. So because the number of positive charges is equal to the number of negative charges, right? So, and then Thomson, though he explained that the atoms are electrically neutral, the result of the experiments which were being carried out by scientists in the later time could not actually give a proper explanation to the Thomson's model. So that is why Thomson's model of atom did not give a positive result, and that is why it failed. So after Thomson, it was Rutherford's model of an atom. And what happened, Rutherford actually he selected a gold foil to perform his scattering experiment, that is by scattering by the alpha particles. Sorry. So when he was actually trying to take out his experimental investigation, what he did, he wanted to know that how electrons are actually arranged inside the atom. So what he did, for his experiment, the fast moving alpha particles were made to fall on a very thin gold foil. And why did he selected the gold foil for his experiment? Because actually he wanted a very thin foil. So he selected gold foil because it is a highly malleable metal. So he can make it into a very thin foil, and because he wanted a very thin layer as far as possible, and this gold foil was about 1000 atoms thick. So and then this alpha moving fast alpha moving particles, because alpha moving particles are what? Alpha particles are what? They are the helium atoms, and that is why helium ions, where this helium ions has a high mass of 4 atomic mass unit, and then also it can move very fast. So these alpha particles were selected for his experiment, and they were, as I told you, that the alpha particles are doubly charged helium ions, right? So that is why he selected the alpha particles for his fast, because it is fast moving and it has a high mass as well, and then it was allowed to fall on the gold foil, and he actually expected that the alpha particles will be deflected by the subatomic particles. What do you mean by subatomic particles? That is the electrons or the protons, okay? And then in the gold atoms, because the alpha particles were quite heavier than the protons, and that is why he did not expect that there will be large deflection. But what happened, he found that the alpha particles, whatever it may be, the experimental results that was being given by the scattering of the alpha particles, actually it surprised him, because what happens, most of the fast moving particles, most of the fast moving particles, they pass straight through the gold foil without any deflection, and then some of them were deflected by the gold foil by small angles, and every out of 12,000 particles, they appear to rebound. That means they came back. So the result actually surprised Rutherford in a very because he did not expect that the particles, alpha particles, will come back, right, and they will be deflected by such large angles. So he told that the result was almost incredible, because like as if what happens if you keep a 15-inch cell on a piece of tissue paper. You just see the tissue paper is such a thin paper, so if you keep a 15-inch cell on the tissue paper, then what happens, it will come back and hit you. So that means you just imagine that the gold foil was as thin as the tissue paper, and just imagine a 15-inch cell, you are striking it over the tissue paper, and then what result would you expect? You will expect that the tissue paper will be torn off, obviously, because it is so light. But what happened? It surprised you because the shell came back and hit you. So that is the result was as surprising as such. So that is why the surprised to get such type of result. And then if you think about a person, means about a child who stands in a wall with his eyes closed, and then what happens? That is what happens. Actually the child with his eyes closed, he is in the open field, and then he throws stones from a distance. Then what happens? He will hear a sound where every stone strikes a wall. And if he repeats it this 10 times, then what you will find that the sound, he will get the sound 10 times. And then, but if the blindfold child, he throws a stone at the barb, that means the crisscross fencing, no, barb fence, then what will happen? Some of the stone might pass without any through the holes, and then the same thing happens with the gold foil. Ruhua. So that is about Rutherford's model, and this model could not could not explain the real theory about the structure of the atom. So this Rutherford's model also failed, though he postulated that there is a positively charged center inside an atom, which is known as the nucleus, and nearly the mass of an atom, it resides in that nucleus, and also the size of the nucleus is so small as compared to the size of the atom. So that was the postulates of Rutherford. We'll have further discussion in our next class as a revision part. Till that time, please go through the video, and thank you for watching the video.